Hello everyone, in this video I will show you how to use the transform class in Unity to change the transformation of any object during the runtime. We will gonna create three scripts, one for the translation and the second is rotation and the third one is scaling. So here we are. You can see that we have a very simple scene in which I have just a one plane and a sphere and a cube. Okay, now what we're wanting here is that if I press the up arrow key, then it will move to forward along the z-axis. And if I press the down arrow key, it will move backward. Okay? And if I press the left arrow key, then this object will move to the left. Okay. And if I press the right arrow key, it will move to the right. So this is the behavior I want to have on this object. To give this kind of behavior to our object, we have to write some kind of behavior. And this is all accompanied by a C# script. So let's write the C# script, hit the add component button, create the new script called translator. Now we have to open this in Visual Studio. Okay. So first of all, let's delete this stuff. And now we have to first of all define a parameter which will shown in your inspector so that we can tune our movement. Let's public float speed. Okay, let's just 10.0f. Okay. So what is this? It is the distance in units per second. Okay. So this is our speed. And then we have to create our update method in which we will write all the movement code. So first of all, we have to access the transform property. And now with the help of dot operator, we can access a function in the transform property, which is called the translate. Okay. Now it will take a direction in which we have to move, and this object on which this script is applied or attached will move through the vector 3 translation displacement that will give it to this function. So let's write this vector 3 dot forward and multiply it by speed. And now to be able to see this movement independent of your CPU performance, that means your frame rate, so we have to multiply with time.delta time, which is nothing but the time interval between the last frame and the current frame since the last frame, right? And it is a very small quantity, so be careful about that. Okay, now we have to apply a condition to this. If input.getKey, input class is a static class in Unity engine. It provides very helpful functions. Here we are using getKey, which is responsible for getting the input from our keyboard. GetKey, key code, and this is an enumeration in which all the keys are mentioned, and we can choose any of these keys. So let's up arrow, now included in curly braces, and now similar to this, we can write all the conditions and behaviors. Down arrow, transform, translate, vector 3, and this time we have to type back and multiplied by with speed multiplied by time.delta time. And then we have to apply another condition for the left and right movement, like this one. We have to type the left arrow and then translate vector 3 dot left, okay, multiplied by speed multiplied by time dot delta time. And now for the right movement, get key code dot right arrow and then transform.Translate vector 3 dot right multiplied by speed multiplied by time dot delta time. And this is the whole script that we have required to give the behavior to our object. Let's go back to the Unity editor and see what happened. Now, so we have the speed of 10 units per second. Now let's hit play and see what happens. Now you can see that we can move around with the help of our keys in your keyboard, and it is moving pretty much nice. Let's detach this script, and now we have to look another feature of the transform class. The first one we have already talked about, the translation, and the second one is the rotation. So let's rotator, create the script. Let's open it in the Visual Studio, reload it, delete this stuff. Now, what we want to have to rotate this cube along the y-axis with time. And I'm not gonna use Unity input class to rotate our object this time, but I will just show you how you can use the rotating function of the transform class. And it is your exercise to do the same with the help of your keys in many directions, right? Let's write the script. First of all, we have to define a parameter which will be responsible for the angular speed. We can adjust the value of this parameter in the inspector, right? We have to write the parameter public float and angular speed. Okay, let's hit the 90 degrees per second. Okay, this is our unit, degrees in per second. And now we have to create our update method in which we have to write all the behavior. Okay, now we have to first of all access the transform property, which is of transform type, and with the help of dot operator we have to access a function rotate, and this function takes vector 3 value, where this vector will represent two things. The first one, the direction in which we want to rotate this object, and the second thing, how many degrees we want to rotate it, and this is described by the magnitude of that vector. So we want to rotate our object in the up direction, that is y direction, up, and multiplied by angular speed. This is the magnitude, and multiplied by time dot delta time, so that it will be independent to our frame rate, and also it will be responsible for adjusting this value altogether so that our final result will be in degrees per second. So this is what we want to have. So let's see the effect in our Unity editor. Now here we have the speed of 90 degrees per second. Now let's play and see what happens. Now you can see that our cube is rotating very nicely. So this is how the rotate function works, right? Now you can see that our y value is also changing here. So transformation is all about changing the parameters of this component, which is of course transform component, right? And there are many much stuff in transform class, and we will also learn in the subsequent series of the beginner series in Unity engine, right? And the third one is the scaling, and you can see that here is the scaling, and which has the 3 parameters. This is also a vector quantity, and we can change any of these parameters to see the changes in our sine wave, right? So what we want to have here is the sine wave expansion. That means the object will first increase its scale and then decrease to 0, right? So let's see how we can accomplish this with the help of runtime script. So let's remove this component and create another script called scaler. Let's open it in Visual Studio, reload it, and remove this stuff. Okay, so first of all we have to define a parameter which is max scalar offset. That means how much the maximum scale can be of this object. So let's public float max scale equals to, this will be offset equals to 1.0f, and then we have to write all the code in the update function, and we have to define another parameter which would be a private one, float original scale, and we have to assign the value with the help of the start function. Now and this function will called only once at the start of our game, right? And then we have to assign this original scale equals to transform.LocalScale dot y, or we can have x, or we can assign x or z, because all the values are same initially in our Unity editors. You can see that all the values have just one. Okay, so we are assigning the y, and now we have to access our transform property, and then we have, with the help of dot operator, we have to also access the local scale property of this transform property, which is of course is of type transform class, right? So let's give it vector3.1, and this is the shorthand for writing vector3 1, 1, 1, right? And multiply it with our original scale plus max scale multiplied by mathsf dot sign, which is, and pass the time argument. Okay. Now we can also add the third parameter, which is called speed, like this. Let's it be 1.0f, and then multiply this with time. Okay. Now let's see what effects it reflects in the Unity editor. So there is an error, sorry. Okay, hit play. Now you can see that it is nicely scaling. Okay. This is pretty much for this video, and in the next video we will see how to deal with the local space and the world space coordinates, right? And we will also see that how the inverse transform works and how the transform direction works, and all this stuff will be well explained in the next video. Thanks for watching.